You ever click play on a movie and it just works instantly? It kind of feels like magic, right? Well, it's not. Behind that seamless connection is a powerful, super complex piece of hardware. And today, we're going to pull back the curtain on that hidden brain, the thing that really powers your high-speed fiber internet.
I mean, we all know it's more than just a cable plugged into the wall. So what is it actually? What's the piece of tech that's juggling all those signals, all that data, literally at the speed of light? Well, let's dive in and find out. Look, the demand for faster, more reliable internet is, well, it's everywhere. We all feel it. Airports, hospitals, even just streaming a show from our own couch. We need a network that can handle everything we throw at it, and then some. And that vision, that high-speed future, it's all built on a foundation of light, on fiber optics. You gotta remember, for decades, networks ran on these thick, bulky copper wires. Think about it, crowded equipment rooms, crazy complex wiring, and massive air conditioning bills just to keep everything from melting. It was just so inefficient. But optical LANs, whoa, a total game changer. They take everything, your voice calls, your video streams, all your data, and put it all onto a single streamlined fiber architecture. And the result? It's way simpler, way faster, and can slash operating costs by up to 50%. That's huge.
So how is this even possible? Well, the tech that makes this giant leap is called GPON. That stands for Gigabit Passive Optical Network, and it's basically the worldwide standard now. We're talking about delivering insane amounts of bandwidth over a single, tiny strand of glass. This isn't just a small upgrade, you know? It's a total transformation of what a network can even be.
Okay, so at the very heart of this whole fiber revolution is a specific piece of hardware. And for our story today, this is the main character. Let's meet the Nokia 7360 ISAM FX. This is what's called an OLT, or Optical Line Terminal. Now, the best way to wrap your head around what it does is to think of it like an air traffic controller. Seriously. But instead of planes, it's managing billions, and I mean billions, of tiny pulses of light. Its job is to make sure every single packet of your data gets exactly where it needs to go without ever colliding.
And let me be clear, this is not just some simple switch you'd find at an electronics store. No way. This thing is built for massive, massive scale. It supports the tech we use today, like GPON, but it's also ready for what's next, like XGS-PON. It's the kind of gear trusted by the biggest network operators on the entire planet, and that's because it's designed with one crucial idea in mind. It's future-proof.
Okay, so that's the big picture. We know what it does. Now let's pop the hood and really see what makes this thing tick. First thing you notice is, it's not a one-size-fits-all kind of deal. The whole platform is modular, so it can scale to fit whatever you need. You've got the smaller FX4, perfect for an office building. Then there's the FX8, for something bigger, like a hospital or a hotel. And then you have the absolute beast, the FX16, which can handle thousands and thousands of subscribers. That flexibility, that modular design, is totally key.
So when you look inside, you find the core guts of the machine. You've got the Fantech card, that's the main brain. Then you have the line terminator cards. Everyone just calls them LT cards, and these have the actual ports that connect out to all the users. And finally, there's the NT-IO board, which handles the gigantic uplink to the rest of the internet. It's just a really powerful, super reliable system.
And just to give you a sense of the sheer scale we're talking about, that brain, a single Fantech card, can manage a database of 128,000 unique devices. 128,000. That is an absolutely insane amount of traffic for one little card to keep track of. Okay, so you've got this incredibly powerful box of hardware sitting there. But how do you control it, right? How do you actually tell it what to do? Well, you don't just get a mouse and a pretty graphical interface. Nope, the engineers, they speak directly to the machine in its own language. It's called the Command Line Interface, or CLI. It's this specialized, text-based language that gives them ultimate, granular control over everything. So, you need to see if a physical connection is live? Bam! You type show port. You get an instant, no-frills status update. Simple, direct. Worried the whole thing is getting a little too toasty in the server rack? You just run show equipment temperature, and boom, you get an immediate reading from every single one of its internal sensors. And then, after you spent hours configuring everything just right, maybe the most important command of all, admin save. Because if you forget this one little step, all of that hard work could be totally wiped out on the next reboot. You literally have to tell the brain to commit your changes to memory. Okay, so all of that sounds pretty great in theory, right? You've got the powerful hardware, you know how to speak the language, but what happens when things just go wrong? Because, in the real world, things don't always work perfectly right out of the box. So let's dive into a real-world troubleshooting story from a network engineer who is wrestling with this exact piece of gear.
So this engineer is setting up one of these units, and they just hit a complete wall. They're staring at the diagnostic output for one of the main uplink ports, and they see this super cryptic message: TX power, no power. The port is completely dead. Nothing.
And this is where the real head-scratching begins. They check everything. Is the port turned on in the software? Yep. Can it see the light coming in from the other end of the fiber? Yes, it can. The system even recognizes the little plug-in module, the SFP. But for some infuriating reason, it just will not transmit anything back out.
So after trying different ports, even swapping in a whole new controller card, the engineer has this aha moment. What if the problem isn't the configuration? What if it's not a broken port? What if the hardware itself is just rejecting the part they plugged into it? They start to suspect that the third-party modules they're using just aren't supported.
And bingo, that was it. After all of that complex troubleshooting, pulling their hair out, the solution was ridiculously simple. The second they plugged in an official Nokia-branded module, the port lit up. Instantly. It's a pretty powerful lesson, right? Sometimes the brain only wants to talk to parts it already knows and trusts.
This story gives us a perfect window into the two sides of our internet infrastructure. On one hand, you have this incredible mind-boggling power, and on the other, this surprising, almost picky sensitivity. So, behind every sleek, modern space you're in, every office, every home, every coffee shop, there's this hidden layer of technology humming away. It's a complex, powerful, and, yes, sometimes finicky ecosystem of hardware and software that we literally all depend on every single day. So, the next time you stream a movie or you jump on a video call and everything just works perfectly, will you think about that silent box of light tucked away somewhere, that hidden brain making it all possible?